Welcome to this training on the new HVM cluster layout version 1.3, which includes the removal of Pacemaker as the GFS2 storage cluster policy engine. In this training, we will be discussing how GFS2 was handled previous to layout version 1.3, what the changes mean going forward, the prerequisites before performing the upgrade process, and post-upgrade validation to ensure everything is working as intended. Previous to cluster layout 1.3, Pacemaker was relied on as the resource manager or policy engine. It would observe the reported state of CoroSync and make fencing decisions based on the information provided. CoroSync is the coordinator. It tracks what nodes are connected or not and determines if there is quorum based on that. DLM takes that information and says if a node is safe to touch the shared state storage. And then GFS is that shared state file system. While stable in isolation, this model assumed Pacemaker was the sole authority. However, Pacemaker was unaware of orchestration goals and workload dependencies or administrative intent expressed through Morpheus. After the upgrade, the Morpheus agent becomes the high availability control plane. Pacemaker is intentionally stopped and masked to prevent it from making autonomous decisions. Morpheus now owns fencing, failover, and self-healing logic using its platform-wide visibility. Underneath Morpheus, the data plane remains intact. CoroSync still provides cluster membership and quorum, DLM enforces locking, and GFS2 ensures file system safety. Before beginning the upgrade, you want to ensure a few things. All GFS2 clusters must be in a healthy state. The Pacemaker cluster must be in a clean and healthy state. Sufficient resources for workload migration exist on the cluster. All backups are done and current, and you want to have a maintenance window in which to do the upgrade. The upgrade process follows a well-defined timeline designed to minimize risk and preserve system integrity. During the pre-upgrade phase, Pacemaker remains active while the system performs extensive read-only validation checks. These checks confirm cluster health, storage accessibility, and operational readiness. At the commit boundary, the upgrade transitions from rollback safe to forward only. It's at this point that Pacemaker is stopped and masked, and Morpheus formally assumes the high availability control. After commit, the system enters its new steady state, where Morpheus manages HA decisions and the data plane continues operating normally. Understanding this timeline is critical for interpreting logs and system behavior during the upgrade. In Phase 1, the following tasks will be completed per host. The agent on the host will be upgraded. Then the host will be put into maintenance mode, evacuating all workloads. Pacemaker is set to unmanaged, but not stopped. Maintenance mode is then exited. During this phase, everything but the agent installation can and will be rolled back in the event of a failure. Once Phase 1 completes and the post-update script begins, you've hit the commit boundary, and rollback is no longer possible. In Phase 2, Pacemaker is stopped and masked. HA ownership is transferred to the Morpheus agent, and CoroSync is revalidated. Once the upgrade completes, you will notice that the architecture is mostly the same. The Morpheus agent now determines what nodes are allowed to interact with the storage based on what CoroSync and DLM are telling it. CoroSync still manages the membership and quorum, DLM still manages the lock space and determines which nodes are safe to interact with the storage, and the GFS2 data layer itself is still the file system. Now, post-upgrade, you can run a few health checks on the cluster to ensure everything is working as it should. Start with the Morpheus agent. Check that it's running and that it's the latest version. Then you can validate quorum with CoroSync quorum tool. You can check DLM for fenced nodes. You can check the mount point for the GFS2 data stores that you're running, and then validate the pools are still showing active and without errors with Versh. The Morpheus appliance and agent logs are a good first stop when things go wrong. You can tail the appliance UI logs with Morpheus CTL tail Morpheus UI, or just view them in the UI. You can check the configuration of the agent with the Morpheus node CTL show config command. This will show you things like the connected appliance URL, the agent API key, and the collector thread count. And of course, you can tail the logs with the Morpheus node CTL tail command. This streams the log file in real time, so you can look for errors and issues. Now, when it comes to troubleshooting CoroSync, you've got some options. Check the CoroSync service, start, stop, restart, all of that. You can look at the logs under var log CoroSync. You can check the configuration file in etc CoroSync. You can verify cluster membership. You can check quorum, and you can test connectivity. And we'll cover some of this in the demo. Now, DLM has its own service and log files that you can check. You can also check the node participation and the log spaces. Okay, that's enough talking about it. Let's go ahead and jump into a demo and walk through the whole upgrade process. Okay, let's go ahead and jump to the demo. One of the things that we need to make sure that we do is just follow our checklist of the pre-upgrade requirements. So we are going to head over to infrastructure clusters, and you can see here all my clusters are now refreshing, but I've got one cluster that's still on cluster layout 1.2, and that's the one that we're going to look at upgrading in this demo. So I'm going to click into this cluster, and we want to make sure that we are seeing what we want to see. So if you'll remember, we need to make sure that all of the GFS2 data stores are in a healthy state, as well as the pacemaker cluster. We can see here we have pacemaker running in a good state. We know which ones they are here. Our current DC or designated controller is HVM02. And we've got a single data store. We can go over to Storage tab and look at our GFS2 data store, renamed in the new version here to HPE Clustered Data Store. But you can see its online status is good. So we're looking okay there, right? The next thing that we want to check, for me personally, is just validate on the back end. So I've got an SSH session here to all 4 of those hosts. And I'm just going to run a PCS status command, and that's going to give us the same kind of outputs that we would see on the front end. As we're sourcing more and more of this in the UI, this is going to become more of a support thing. But since we're getting to a state where pacemaker is not going to be used, these commands are only useful up until this point, and then they become completely useless for us. But you can see our current DC, as stated in the UI, is HVM02. We have our nodes that are all online, and we are in a good state from a pacemaker status. Now, the next thing that we need to look at is availability of capacity in our clusters here. So I'm going to come over here and look, and we're going to see that we've got a bunch of VMs here. What is this, like 12? I think it's like 12 VMs here. We go to our hosts, and the way that this is laid out, I can actually come over to the back end here. We'll come back in and clear this out. So we're going to versh list -- all. Now, this command's not going away. Yep. So we've got 3 VMs running on each host currently. Okay. So I'm going to get over to our hosts, and we're actually going to go into one of those and take a look at the current availability here. Let's get into that one. So in the host, we're going to see a few different things here. So firstly, you're going to notice that the agent is out of date. So once you upgrade to 9.0, you're going to have to upgrade the agent. However, for the cluster layout update, we're actually going to handle that for you just on the hosts. We're not going to do the VMs for you. But we're going to look at a few things here just to make sure we have the resources that we need. And memory is going to be the big one here. So Morpheus memory, this is basically the memory that's on the host. So 19.5 gigs is available from the host. When we get down to the capacity info section, you see we've got 15.5 max. Reserved memory is 4 and allocated memory is 12. So 3 VMs per host at 4 gigs apiece. That gives us that 12. Reserved memory is what we reserve on the host by default in the system so that the operating system has room to breathe. And then our max memory, this is basically what can we allocate. So we can allocate a total of 15.5 gigs on this server. We already have 12 plus the 4 here, right? So that puts us at 16. And that only leaves us with 3.5 from the total memory. So hopefully that's making sense. So we've got our allocatable memory being 15.5 available because we removed this 4 from the 19.5 total memory out of that pool. So if we try to move one more VM over here, we have not enough resources by half a gig. And I'll prove that to you. We'll go into the VMs here, and we will go to this one. Why not? And we'll go to actions, and we'll go to manage placement. We'll just put it wherever. It doesn't really matter. We'll go ahead and save the changes. Now, because all 3 hosts or all 4 hosts, have 3 VMs running at 4 gigs. They're all 20 gig hosts. None of them have enough room for any of these VMs to move off. I did that on purpose because I want to show you a couple of things that you can do to make it past this. One of them is a feature that's been around for a while, or capability, I should say, and the other is a new capability that is being introduced. Okay, so first thing we want to do is we'll get back to our host and take a look again at our capacity info. And I'm going to go into edit this host. Now, under advanced options here, if you haven't seen, this is where the reserve memory is set. By default, it's set to 4 gigs regardless. You can change this and lower it. So I could actually set reserve memory to 2 gigs for this. And then each host would allow me to move 1 VM over to it because it would have a little bit of space. We've got, 3.5 gigs. If we switch this down to 2, that gives us 5.5 gigs. Every system is 4. We'd be able to move everything over. But introduced in the latest version is our overcommit. So our overcommit here, %, this allows you to allocate more resources from a host to guest VMs than it actually has. So basically allows you to say, I want to be able to allocate X amount of memory, because all the guest systems are not necessarily using all of the memory at the same time, and they're not maxing out the memory that they have allocated to them. So this allows you to commit more of that. So right now, our % is 100. So we are at 100% of allocatable resources. When you want to overcommit, you just have to go over those resources. So I'm going to just go ahead and change that to 200 as an example. I'm going to go ahead and save my changes. Okay, and what we should see happen is this commit % will now go up to 200 and our max memory should update. Do a little refresh, yep. So now my max memory on this host is 31 gigs, even though I've only got 20 gigs on this particular host. This is not a cluster level configuration, so you actually have to do that on every host. So I'm going to go ahead and set all of my hosts up with 200% overcommit, and then I will come back. All right, all of my hosts have been updated and now have 31 gigs of committable memory. So we should now be able to do our migration. We'll just do it live. We'll find out if this works in the upgrade. So the last couple of things that we need to validate for our pre-upgrade is ensure our proper backups are completed. And this is a dev environment that I use specifically for beating up and testing things. So I don't really back anything up except for the manager itself. And that is not really a concern for what we're doing right now. So while I do have a backup of my manager, it's not pertinent for this conversation. And the other thing is to make sure that we're doing this during a maintenance window, just in case something does cause issues. So I am always in a maintenance window because that's pretty much exactly what this thing is for. And we will go look at doing our upgrade. So from the root here, from our cluster, all we got to do is go to actions, and update is our option right here. So I'm going to go ahead and select that. And our only option here is that cluster 1.3 upgrade. And this actually tells you everything that you need to see, right? What is it going to do? It's going to decommission pacemaker, transition the GFS2 mounts to the Morpheus agent, decommission it on each host. There's no GFS2 file system changes. It's just mount management. Okay. The configuration updates take us to 1.3. And here's what happens. Each host is placed in maintenance mode. The hosts are upgraded in a rolling rotation to maintain availability. Workloads are migrated off each host during their maintenance window. That's why you have to have sufficient capacity. And the estimated downtime per host is 15 to 30 minutes. Now, it's going to be dependent on your environment, your hosts, and how heavy the workloads are on them. And this is that list, right? Before we begin, make sure all GFS2 data stores are healthy and mounted. Confirm pacemaker clusters in a clean state before starting. Verify the storage and memory capacity for your workload migration. Get your backups in order and make sure you're in a maintenance window to do this. And then what happens? We do the agent upgrade if it's below that minimum version. I've already seen my hosts are, because they have not been upgraded since I did the upgrade to the appliance, because I wanted to show that part of it. Once the agent's upgraded, it'll enter maintenance mode, migrate things off. it'll execute some scripts to decommission GFS2 and then exit maintenance mode. After that's happened on every host, that's when it's going to start those post-update scripts. And that's that point of no return. So everything up to step 4 here, if something goes wrong, it can revert. Now, it's not going to revert the agent installation. The agent needs to be at the new version anyway, so that stays. But basically, it just puts Pacemaker back in the mix on that host until we can come back in and find out what's going on. Hopefully, we don't run into that, but we're going to find out. So it even says here, if any hosts fail during step 1 through 3, all previously succeeded hosts are rolled back automatically. So if any host, so you make it through 3 of them and then one of them fails on that update script, all of them get the pacemaker put back together. So I'm just going to hit execute and we're going to watch it. I'm going to head over to the history tab and we will see what happens as the cluster gets upgraded. What will most likely happen is I will speed the video up so that you just don't have to sit here watching paint dry. Or I might stop it. We'll see what happens here. So we'll get into our history. I'm going to expand this out. So it's just going to start by upgrading the agent. We'll watch it walk through the first bits just to make sure that everything is good. So unfortunately for you, you got to listen to me ramble for a bit while this is going. Now, a couple things that you can do if you wanted is on the back end, on the host nodes themselves, you could run that Morpheus-node-ctl tail command and kind of watch what's happening on here. If you wanted to have another session open to the actual Morpheus appliance, we can get in there as well and do a Morpheus-ctl tail Morpheus UI command. And this one will run the logs on the manager. So we're trying to enter maintenance mode right here, so we should see systems moving off. Another thing we could look at here, so we're on O2. So if I just come over to O2, stop the logs on that one, and just do a versh list all. So we've only got 2 running on here now, so we're making moves, and that was moving to O4. So we can, if we wanted to, just kind of chase the VMs as they're going. So O4 has now got 4 running on it. So we should see this update. Oh, and we had a failure here. Let's see what it tells us. UI is running a bit slow. Failed to move servers. Check history details. So let's go check our logs and see what that gives us. Nope. Do we have any errors? Let's see. As we see, failed to enter maintenance mode, server check. Let's see. Is this going to tell us anything here? This tells check history details. Well, that's not very helpful. So we can see, I guess we could cat that log if we needed to. But let's see what happens if we try to move a VM. See clusters, go back in, and our hosts. So we're moving off of O2. And let's see if it lets us move things around a bit. Here we go. Get into our VMs. Now I know that one was going to O4. So why don't we just see if we can put that one on O4? See if it gives us any kind of indication here. Go to our history tab. Do a hard refresh on this so that it starts showing what we're doing. Okay. Move, move, move. Nope. Maybe we just had a hiccup. take a look. So run that verse list. Looks like it's moving. Verse list. Did I? Oh, helps if I would type, right? All right. So we've got all of those VMs running on here now. So this will probably show is completed. Yep. So it's not that. I wonder. It's also showing the agent didn't get upgraded, but that should have happened first. Maybe that's just once the cluster refreshes, it'll show that. That could just be a session issue. All right, let's go back and let's try this again. Now, when we run this again, because things are able to roll back, it just picks up where it left off. So if the agent's already installed, good for us. And it'll just try to move forward from there. But it might not pick the same host to start with. So let's hit this update again. And execute. And we'll go over to the history. Now, again, this might take a minute. It might just run fine this time. So I'm going to go ahead and hit pause on this. And I'll come back when we either hit a roadblock or we succeed, and we'll pick up from there. Okay, this did finally take, and I've got a theory about what happened. I had a couple more failures. And I'm on a pre-release build of this, so I'm sure we have this figured out by release date. But one thing I had noticed, you see I've got 4 failures here, and it seems to fail on each host once. But one thing that I did just to test, I increased the overcommit on this, and once I did that, the thing ran no problem. So I have to go look and find out. I don't have any detailed troubleshooting steps on that because once I ran it this last time, it just went through and completed everything. So we're going to go through and look at the sync status on everything and do some of our validation. And then in a later training, we'll dig into some deeper troubleshooting steps. So here we are. Just to go through what actually happened is we went into maintenance mode. We moved the servers off. Now, again, in the first run, each time that this ran, it installed the agent, so it doesn't have that agent installation at the beginning of each of the hosts now. So you could do that ahead of time if you want. But it doesn't show up in the history here. But if we go down to one of the failed ones, we'll see the agent getting installed. So it goes in, moves some stuff off, updates pacemaker, and then exits maintenance mode. And then we get to the post update scripts here. So we got post update on HVM. So we're just configuring CoroSync, stopping pacemaker, marking it locked so that it doesn't ever get turned back on. And that happens on each host. Okay. So with that, overall, pretty easy, right? There's just the prerequisites that we gotta be aware of. And what can we go look at, right? What does that post deployment state look like? What kind of things can we go look at? Well, we already had our host environment up. Let this sit for a bit too long. Okay. Go ahead and get this going again. Let's go ahead and let that go and clear. Okay, so we got all those. On the hosts, again, you can hit that Morpheus CTL, node CTL. Sorry, we're on the hosts, node CTL tail, and see if you can see anything going. But another thing to validate, because we do have a new agent on this one, is actually the Morpheus node CTL version command. Okay, now we're on 3.2.4 like we expected to be. So we were on what, 3.1.2 or something like that prior to this. And it even tells you what OpenJDK version that we're running there. We want to make sure that CoroSync is looking good and DLM are looking good. so we have that CoroSync quorum tool, right? Quorum tool command. Okay, and that shows us our expected votes, the highest expected, our total votes, and our quorum. So we are in a good spot here. And then we also have, so the DLM tool, and you can just do an LS with that one. And it'll show you, here's members for, here are the member IDs. And you can kind of get that from that CoroSync. We can see node ID 1, 2, 3, 4. Those equate to these host names here. You can also do a, let me get that on all of them here. Instead of DLM tool status. And then you can see a little bit more here. So what this is going to do is on each node, so node ID 1 being O1, the local one here, this is showing that it's a member. It's seeing adds and removals across some of these. So this is since last reboot on the system, and these systems have not been rebooted for a while. We had the old pacemaker. So once you do a reboot on these hosts, which is not required for this upgrade process, but once you do, you'll be able to see this go back down to 0, and you shouldn't see a whole lot of adds and removals. That means just a lot of flapping going on in the environment. Most likely due to this being a nested lab that I am constantly messing around with. But it's good to see when you run that DLM tool status command, you can actually see how many times a node's been added and removed based off of what every other node in the cluster thinks. So just something to be aware of. Now we can also do make sure that our mount is still good, right? So mount, we'll just grep for GFS2, GFS2. Okay, and that shows us where it's at, our type GFS2, where it's mounted, and where it's configured from. You can also do your versh pool list, all, -- all. So that shows all of them, right? The GFS2. And then if we want to know specifically about our GFS2 data store, it's info, if I can type info, and then the pool name. So because I got a space in this, I got to quote it GFS2 data store, because I can't type and talk at the same time. And now you can kind of see what information we have on it, right? It is running. We can see the capacity on it, and we are in a good state. Now, of course, we can always just go to the UI and look at our storage tab. This thing runs slow because it is nested. Refresh this guy and let that go. Spazzed it out. All right, so we go back to our data store. We can show that it's online. We're looking good there. And another thing to come look at is you'll notice that the pacemaker tab is not there anymore. Now we have the quorum tab, and it shows our designated coordinator, how many are reachable, and you can see we've got 1 and 3 are looking unclean, so I probably need to go do something there and get those rebooted and get them brought back in. So we should take a look. Are all of our VMs reporting okay? Okay, they are reporting okay. So we saw that there was a lot of flapping on those 2 nodes, 1 and 3. So that's probably something networking going on. So that is for another video troubleshooting the GFS2 data store without CoroSync. But hopefully this one was helpful, just getting you through the upgrade process, things to look at. And if you need any more information, just feel free to reach out to us and we'd be happy to help. Okay, I lied. I can't leave this. So we're going to do a little bit live here and see if we can't figure out what's going on. Now you'll notice here, this shows cluster service not running. I kind of clicked over and took a look at that. This is on one of the hosts that showed that it was in error. And again, if we came back over here, I ran a systemctl status DLM, and you can see that it's failed. And I bet we're going to see the same thing here. But before I run that on this other node, you can see the ones that were flapping, and then you can see the fences and a whole lot of stuff is happening. And then on these other 2, they're fine, right? Now this one's showing, some fails and some fences on node 4, which I believe based on this is, HVM 04, which is this guy down here. But it's not a massive amount, right? So this could have just been there from prior, but we do have DLM failed on both of these. So let's see, system control, status DLM. Oh man, I'm so good at typing. Okay, so yeah, we're failed on both. So how are you doing? Okay. All right, so let's just try to start it. Let's see what happens. The control process exited with the error code. So now we're going to want to look at our journal control DLM service. Real-time troubleshooting. Here we go. Finished with the failure. The job result has failed. So we've seen a lot of failures here. Lock file set. We got an error on the lock file. So if we have an error on the lock file, this controller is not allowed to actually access the lock. It has been kicked out. So I bet we'll probably see the same thing here. Let's go ahead and try a start just to see if it gives us the same thing. It does. Yep. Here's our lock file error. So this is still a GFS2 cluster environment. So even though pacemaker is out of the way, generally the only clean way to get out of this is to reboot the host. So I'm going to, I've done this cluster upgrade. This is my fourth one now. This is the first time I've actually seen this happen. So it could be due to the build that I'm running today while doing this. Maybe we just got lucky so we can actually do a little bit of troubleshooting. Who knows? But let's see if we can get this host into maintenance mode. We're on 01. Do we even have any VMs running on this host? Let's see, because it doesn't look like it according to the UI. Versh list. Oh, we don't have any, so we should be able to get right into maintenance mode, so that's a good thing. What about the other? Let's see, did we end up with that in two different spots here? Versh list. Oh, okay, so this one's got a bunch running, so we should be able to start here, get 3 up, have decent quorum, and then we'll see what happens. So from here, we'll just go ahead and restart. And I will come back once that reboot is done. Okay, after having come back from the reboot, you can see we're in maintenance here. If I go back to the summary tab, you can see we have 3 online now. 1 on clean. Get this guy to open up for us. And there we go. So we got 3 online. So we're going to go ahead and take this one out of maintenance. Again, this isn't meant to be a deep dive troubleshooting. So we're just going to see if we can get out of this from just some basic troubleshooting steps. And this very well could have also been caused because this is a nested environment and not necessarily something you'll see. Like I said, I've done this upgrade now. This is the 4th time I've done it and I hadn't seen this happen. So possibly an environmental issue, but it's always good to see these kind of things in action live. So we've got that going. We're sitting in provision state now, so this host should be able to start accepting workloads. So what if we head back into our cluster? And we know O3 is housing some VMs that we want to get off there. So we're just going to go ahead and test out migration real quick before we try putting it into maintenance and see if we run into any issues. The VMs, let's grab it. Just you. You can see here all the VMs are now out of date on the agent as well. Let's see, manage placement. Let's go to 01. That's one we just brought back online. And migrate. Let's see what that does for us. History. We're moving. Let's see if we can see that come into life on 01 here. This is Versh list. All right, so let's pause. It looks like it's going to be moved off here. So we do still have storage capabilities. And one thing you probably noticed when we were looking at the host, all of those VMs are still up. We did not lose connectivity to the VMs. The storage is still there. Just that DLM service is not running properly. Well, at least it's locked out, so it's letting the VMs continue running. Okay, so we're running over here. So what if we do that versh command on 3? Yep, so now it's gone. So we should really be able to just put this host into maintenance mode and bounce it. So let's go ahead and do that. Let's head back to our, we're already on the host. And let's enter maintenance mode. We'll let that run, and then we will do a reboot on this guy. And I will be back from, once it's in maintenance, I'll come back. All right, so 3 is now in maintenance mode. You can see we can do a list all, and no VMs are running. Come back to the UI, we are in maintenance, and there are no VMs running on this host. So in pretty good state. I know earlier I said that CoroSync was out of the way. What I meant was Pacemaker was out of the way. CoroSync is still in the system and running. So even in a situation where it looks like DLM might have an issue, it could just be, like I said, an environmental thing, or the build that I'm running, it was just reporting poorly. But we're going to go ahead and reboot this host, and then we should be good to go on this one. So I'm going to reboot it, and I'll be back. Okay, we are back. Host has been rebooted. We are still in maintenance. And what I want to do is go check and see. We might have to refresh the cluster to get information. Let's go take a look at the cluster and see where we're sitting. Okay, we still show one is fenced. We get this guy open. Okay, so now it's fenced as opposed to not online, which means that we probably saw it go down. They fenced it properly. Let's do a daily refresh and see what we get. Let that sink for a minute. We can, while we're waiting for that, we can go back in and let's see, to our DLM tool status. Okay, we are node ID 3, and you can see how all of the flapping has gone away because it's been rebooted. We can look at the other one as well if we wanted to. So DLM tool status, stout. Okay. So this has seen all of the flapping on 3 before it got rebooted. So we should be in decent shape. Let's see, go ahead and refresh. We're still syncing. Okay. So we should be able to see, let's see. It was the CoroSync command, right? We wanted to run map CTL. CoroSync. We might want to run this from a different machine, but we'll try it from here first. CTL grep members. Join. So we're showing joined here. So yeah, we're probably just waiting for. Actually, let's check it from one of the others just to make sure. Which one is our DC? 01 is our DC. So this is our designated controller. So CoroSync, CMap, CTL. Let's grep for members. Okay, so we're showing joined here for 3 as well. Easy to keep track of in this environment. 1 is 1, 2 is 2, 3 is 3 from the IP address, as well as their IDs. So that makes things nice. Go ahead and hop back over here, give us a little refresh and see if we've come clean yet. Oh, well, I could always try being smart about this, and let's go back to the hosts. We're still in maintenance mode, so that's probably why it's fenced. Always think your way through these. All right, let's leave maintenance. Confirm. Let that go do its thing. Okay, we are provisioned now. Should be able to move VMs to it. Real test would be to move a VM to it. So let's do that. Let's go ahead and grab one. Oh, look, they're all showing online. Let's go back to that summary tab real quick. Yeah, they're all online now. So yeah, it wasn't the refresh. It was just take the thing out of maintenance and it won't be fenced anymore. Oh, logic wins the day. All right, let's see. 19 from HVM 02. Let's go ahead and move this guy. We're just going to validate. Just real fast. Manage placement. Move you over to 03. Save changes. It's much nicer than battling with GFS2 being down when pacemaker is having issues. So happy there. It's actually pretty easy to do. It did take rebooting the hosts, but was able to move things off. They still had access to be able to migrate properly. So we're in pretty decent shape there. You do want to make sure that you have, HA enabled and a heartbeat data store available. My heartbeat data store is actually an NFS data store. I've got an NFS and a GFS2 because I like to test and make sure everything is good. And I just like having everything there. Plus I have to test and show everything. Okay, so it shows we're moved. We are on the hosts. I'll probably refresh here. There we go. We're on 03. And there's our VMs. Okay, so there we go. We did a little bit of troubleshooting. We had a little fun. Got to find some stuff out. Had to do some cleanup. But overall, a pretty easy process. Like I said, the initial issues that I ran into probably had mostly to do with resources. When I bumped up the resource capacity per host to be able to handle a greater amount, it was good. I will say, if you're going to do something like I did in that, make sure that you go put that back down to a reasonable level. I think I put it to like something like 400%. Yeah. I'm not real big on overcommit, so I'll probably put all my guys to like 150, give them a little bit of extra space. But yeah, that part is up to you. We'll have another video on the overcommit stuff come out later. So hopefully this was helpful. And like I said, hit us up if you guys have any questions. Thank you.